Hello and welcome to the next episode of our Refactoring Podcast. This is Andrzej Krzywda speaking, and today the topic is mutation testing. At RCov, we recently experimented in a real project with the tool called Mutant, which is a really good tool for mutation testing in the Ruby world. So I thought, why don't we invite Markus for the podcast and let him tell us more about Mutant, about some more advanced techniques we can use it. So Markus, hello, why don't you introduce yourself?
Yeah, hello. So I'm a first-time podcaster. My name is Markus Schirp, and I'm the author of the Mutation Testing tool. We are here to help people to understand the benefits of mutation testing and how to implement it on a wider scale on real-world projects, which is obviously not really easy to get from the currently released Mutant documentation.
Yeah, however, when we started using Mutant, it was all fine with a little bit of your help. So we were able to set up and start things going. But very quickly, we realized that there is something much deeper in Mutant. And then we had our conversation. And you said things like that you can recognize that something is a mutant-driven design. And I realized that I thought the same, that I can actually be able to recognize when things are TDD'd, but now I think I will be able to recognize when things are mutanted, if it's a word. So what's your opinion on that?
Yeah, I experienced the same, and I call it the MDD, Mutation Testing Driven Design, or however you abbreviate it. The basic point is that there is a rightly known weakness in TDD, which is basically you do a test first, but when you do the implementation cycle, there is a possibility you implement too many semantics, and you forget to add a test for this semantic because you A, simply forget it, B, you are not experienced enough and you use a composition of primitives which does too much, but includes the test you just added, or C, there is a totally unexpected side effect of fulfilling the just added test, which adds lots of other semantics you should actually have tests for. And mutation testing really plugs nicely here because it can actually tell you if there are unspecified semantics in your code. And just as a little spoiler, mutation testing, the way Mutant does it, might not be the canonical way. Mutant is just built as a tool to assist my personal needs. So I sometimes run into problems when people expect Mutant to do things totally different. So there's a big problem right now, in my opinion, that it's totally aligned to my personal needs, and I'm just beginning to get community input, and I actually see the value in the community input. So talking to guys trying mutation testing helps myself a lot, and this is all this podcast is about, to get this kind of interaction and knowledge exchange happening.
Great. And to admit, it was a bit of an accident that we started using Mutant. So we started this thing called RailsEventStore to allow Rails developers to use event sourcing and CQRS and such things in their Rails applications. But the developer who started the initial code, he chose rspec as the testing library. And I'm really not a big fan of rspec. And when I have the choice, I prefer to use Minitest. But then I was reminded of this thing that Mutant doesn't support Minitest, and then Mutant supports rspec. Okay, so let's take advantage of the good things that we have because of rspec, and let's use Mutant.
Okay, and actually, Minitest. There is currently a guy who works at Red Hat, and he has a team who likes Minitest also, and he is a user of rspec in his private time, and he likes mutants so much, he recently PR'd Minitest integration, which in my opinion will make it this time to Mutant mainline, whenever I have time to do the next open source cycle on this PR.
That's great. So yeah, and then we started using Mutant, and I realized that we have some untested code, and I also realized that we have some parts of our of this gem called RailsEventStore that I consider to be core. And because if people use RailsEventStore, it will be like the platform that they will build on, like they're almost the persistence replacement. So I really want it to be totally reliable and never break things, but still allow refactorings if we need it, and have a really nice test coverage. So now we are in the topic in test coverage. And obviously there are several tools in the Ruby community. Some are more popular, some are less popular. So maybe you could introduce us. What is the difference between rcov, simplecov, and Mutant, for example?
Okay, so in my opinion, first statement, rcov and simplecov have equal kind of guarantees. They're basically line tracing coverage measurement tools. And this, yeah, okay. So conceptually, in my opinion, Mutant could be described as a semantic coverage testing tool. And that obviously includes the line tracing thing. Yeah, so the classic counterexample where line tracing or line-based coverage doesn't possibly work is when I have a method and this method has n side effects and these are executed in a sequence and I add a test for the last side effect, I get full coverage while only specifying a small fragment of the available semantics in this method. This is a classic counterexample, and even branch coverage would not find this one because I just say, okay, I write file A, then I write file B, then I write file C, and I only have to add a test for C and get full line coverage and actually full branch coverage because there are no branches. The only known technique to me is mutation testing, which would force me to specify the interactions with shared mutable or side effect for resource A and B.
Okay. So that's the thing with those simpler tools like rcov and simplecov compared to Mutant, is that they don't really give you that much confidence, I think. So it might be a false confidence at some point. If you have even a high coverage in simplecov or rcov, you may break things by refactoring, even when you thought you're totally secure.
Exactly. Even with Mutant is not a silver bullet, but it basically pushes the amount of confidence to another magnitude. It won't solve all your problems, but it solves significant more problems. And that's what I'm interested in incremental improvements to my development activities.
So now that we are at the topic of test coverage and people love to discuss the point of achieving some kind of test coverage. So we need to discuss it. We need to talk about it. And my view is that test coverage does matter. However, it doesn't really matter when you try to, improve from 60% to 70%. It doesn't really bring that much value. But if you are closer to 100%, it brings much more value. And
it gets exponential more value.
Yeah, so I think that the difference between 60 and 70 is less important than the difference between 99 and 100.
Exactly. Absolutely. I totally agree. There is a turning point. So typically when I talk to people about mutation coverage, it's like, oh, so much work, and what's the benefit? But I typically have to convince them to give them a little bit of more forward trust to say, okay, so instead to aim for 100% coverage for the whole project, let's take something tricky, a small unit, and get 100% coverage there. Then you can expect, and then just keep it at 100% coverage. And after one development cycle or two development cycles, look back into the difference of pain this module after achieving 100% coverage and keeping it there. You got from this module again. And after 3 to 4 cycles, I typically get the people to the point they really understand it.
Yeah, and also obviously there's a difference. So if you start with a legacy code base that wasn't really well tested, you have a different starting point. So you need to improve the test coverage to a certain level. But when you start from a greenfield project, so you are responsible for everything from scratch, and you do follow TDD in a well-defined way, then you should have 100% coverage no matter what you do, right? If you do the right TDD.
Depends. So there is a classic TDD where you say I add a test first and I write code, but these cycles do not include running even line tracing coverage tool. You can easily end up with 90% code coverage when doing classic TDD. When doing metric assisted TDD, running a line coverage checker, you still might be able to achieve 100% coverage with classic TDD, but the actual semantic coverage can, depending on the domain, be really low. Look back to the example I gave before with this sequence of n side effectful computations where you only have to specify the last one to get full line coverage. So yes, with greenfield projects, it's significantly easier. And in terms of overall long-term speed, doing mutation testing from the beginning is probably the best idea, but backfilling mutation testing to legacy projects is what I do have to do usually, and this is mostly being done we as a strategy, we basically say, okay, so I change a single class to fix something, to fix a bug, or to add a feature, and I make sure that all units I touch from this moment on at least improve in mutation coverage, or basically say, okay, I try to backfill mutation coverage first, then add the feature and keep it there. So I call it the drive-by mutation coverage principle.
Nice. So recently it was almost at the same time when I started using Mutant more frequently, I also learned about some advanced way of doing TDD, and somehow I missed the whole message from Uncle Bob at some point when he was talking about transformation priority premise. Are you familiar with this concept?
Yes, I am.
Okay, so this is so lucky you, good that you know it before. I didn't know it, so it actually filled the gap in my understanding of TDD, and it also solved the problem that was frequent in my TDDing process when I was doing the first basic steps with TDD, hard coding the values and so on and so on. And at some point you add a new test, and then okay, now it's the thinking part. Now I need to do it right, not the stupid way. And I didn't know transformation priority premise and its rules. It's very simple rules that you can do it very slowly, one micro step at a time. And it really helps by avoiding this kind of gap. There is no longer pause than, 1 minute.
Yeah, exactly. So I typically recommend to run mutation testing on the subject you are currently working on after any decent improvement you had in your TDD cycle. So you don't have to do it on every cycle. You do not have to do it, but you do not have to do it after 2 cycles. It should be your own judgment when you say, okay, I need help here. But before I submit my changes to PR, via RPR, I typically make sure that everything I touch stays at 100% coverage or at least improved. But everything I add totally fresh should be at 100% coverage. And this basically helps me to to do the transformation priority premise correctly.
Okay. What else? What else here? So also when we do the whatever TDD, mutation testing, and all those things, at some point we need to decide what is the current unit you work on. What is your preferred level of granularity? What do you run mutation testing against when you are in the TDD cycle?
This is a very tough question because it depends on the impact of the change. So I typically try to get the change separated into the following steps. So first I fix code style, which always, because my code style, even when I'm on the same project, within 1 month, my code style basically shifts a bit. I shift preferences from quoting preference, whatever. So the first thing I do is to make sure that all code I have to touch is perfectly in line with my code style. The second thing is I fix any known fixmes which somehow belong to the change I plan. So I have a really, really flat and even ground to base my change on. And then I start the typical TDD cycle and try to do the least possible improvement I can possibly PR. So when I'm working on a feature, I typically have to adjust interfaces first to plug my feature in. But I try to get this interface adjustment back into mainline before I start with a real feature branch. So this is obviously the optimum case, but there's a nice thing about splitting even a large change or even a small change into even smaller changes is that the unit of mutation coverage is very, very small. And if you ever run mutation testing on a decently complex code base, the cost and also the execution cost scales exponentially with the amount of subjects or the amount of tests you are including into the mutation test. So splitting your current job into many small ones really helps here to speed up the development cycle.
Mm-hmm. So at some point I wrote a blog post, and at the end I will put a link in the show notes, that classes are not always units. And when I look at typical Rails application, I often see the problem that people test every single class in isolation, and then they mock out everything possible. which I don't find really valuable at some point. So when I want to change it, I have to really change a lot of code.
Exactly.
So, yeah, so you agree here, right? That the class is a bit too low level.
So classes are sometimes a very good guidance to define units, but there are lots of corner cases, or actually lots of counter cases where you shouldn't never think about doing the class as a unit. So Mutant actually looks like it forces you to write tests for every single class and every single interface. That should be probably a dedicated blog post on how to avoid this sort error that Mutant tries to enforce this. I typically have my unit structured in a way that there is some kind of a topper level class, and I try to mutation cover all classes which live into this top level class namespace, which are considered private classes, implementation details, whatever, through the public interface of the unit. There are very rare cases where I actually have to say, okay, I write a dedicated test for this specific edge case because it's so uneasy to target through the public interface, but most likely I'm just cementing a smell there, so I try to avoid this.
Okay, interesting. So I didn't really get this this feeling that Mutant forces me, or I don't know, suggested me to use classes and to test them in isolation. Actually, quite the opposite. We
Interesting.
In the RailsEventStore implementation, when we started without Mutant first. So when we started, we had this facade class called client, and you can do everything possible through the facade class. And below that, as you call it, there we have several private classes. Maybe it's 10, maybe it's 12, I don't remember. So we can change, replace implementation, and even name and everything from those private classes. And the Mutant and the tests are still working fine, and the functionality works fine. So we only test through the public interface. Okay,
but there is a problem that unexperienced Mutant users see a mutation, and the mutation is reported on the private interface, and they try to kill the mutation, but miss the point that they touch this code through the public interface and write a test dedicated against this mutation, not thinking about, I need to kill this through the public interface. So this is what I mentioned before. You did not run into this scenario because Mutant improved a lot in terms of intelligence, or basically convention for test selection. I think this statement I did before was more based on a little bit more historic versions of Mutant. The tool is at least 2 years old right now and ran through several iterations. So I'm really happy that you, as the most recent new Mutant user I'm talking to, didn't run into this trap. Perfect.
Yeah, obviously, we've had several discussions in our team, like how to use Mutant. And I think we also did our mistakes here. But it really helped.
You should blog about this thought process, or write it down so I can review it and improve the documentation based on what you resulted in.
Yeah, I think it was more about the techniques around it than about the Mutant itself. But
what techniques around it? I'm just curious.
Like what to consider to be the core module of our system, right?
So basically it forced you to be very explicit about architecture.
Exactly, and that was a good thing.
Okay, so it's not a Mutant thing. It's basically, it just causes architectural back pressure.
Yeah. So we had to define. So at first I thought, okay, everything is important in our system, right? Let's aim for the 100% of Mutant coverage everywhere. But then I realized that while it's a good goal, it doesn't need to be like very strict goal, because what we did, we set at some point with your help, we set up the continuous integration on Travis CI, and we let it run Mutant after every push, and the build passes only when we have Mutant coverage at some point. And right now this is 100%, I think. So that's the default. So that was good. But then I realized that certain modules don't need to be 100% if there is any really proper reason to not to have 100%.
So I can only suggest that you on the long-term target, whenever you touch these currently not 100% covered modules, you should think about adding them to the 100% covered set over the time. That's only my recommendation, because from my observations, and I try to get 100% mutation coverage on legacy Rails code bases I'm working on, that it, at least while trying to get the coverage, you might not achieve it the first time, you might not achieve it the second time, whatever, but you always find something significant to fix there.
Right.
Okay, so let's talk about testing and with Rails and mutation coverage. So I find it, with having worked with mutation coverage on Rails-infected environments and pure Ruby environments, I find it exponentially harder to deal with Rails in mutation coverage because there is more mutable global resources which basically cause back pressure to the way mutant executes things. So with running mutant against the test suite has to fulfill some basic properties. The first property is that you need to be able to rerun the test suite multiple times and multiple times in the same process, so it shouldn't leak garbage in memory, and it should pass multiple times in the same process, and it shouldn't share values cross processes because of the way mutant parallelizes things. So when using mutant on a traditional Rails code base that has database heavy tests, you run into particular difficulties, and I'm curious if you experience it the same with RailsEventStore.
Kind of, yes. So RailsEventStore, the core of the system, that is not Rails dependent, and I want to keep it isolated from the Rails parts.
Is it tested without loading Rails?
We test it with loaded ActiveRecord, I think, at the moment.
Yeah, that's good, because I always encourage people, especially for mutation testing. It might sound like a good idea that you try to test it in isolation, but because Rails infects everything via monkey patches, that testing some piece of code without Rails loaded is, when it's supposed to be used with Rails, is not giving accurate results, in my opinion.
Okay, so even ActiveRecord might not be enough because some places might use active support, for example, right?
Yeah, when you load ActiveRecord, you load active support transitively. There is no chance to avoid this, sadly.
Sure. Okay, so what we did at first is we followed the architecture that we usually do in Rails applications. So we isolated from ActiveRecord by using the repository pattern. So the repository pattern this is the class responsible for retrieving data from ActiveRecord, but then it repackaged the data into some kind of our data structures and it returns them to us. So what it means in practice is that in the tests, we used InMemory repository. So that was an equivalent of the real ActiveRecord repository. It has the same interface. It returns the same data, but it has a different implementation. It keeps the data in memory instead of like in the database table. So
you can reset this in-memory repository between tests.
Yeah, that's what we did. Yes. So we reset the data in memory. However, this is almost great and was almost enough for us. However, we don't really test the ActiveRecord repository. So we can assume that it's once written, it's always great, right? It works.
Okay. When dealing with basically dealing with this anything ActiveRecord-infected will be interesting for you because depending on what database backend you use, you will run into the problem that multiple concurrently executed mutations will write to the same database, and that can possibly go wrong. On a really big legacy inherited code base I'm working commercially on, we ended up in opening a serializable transaction per test and preventing this transaction from being committed. And this works surprisingly well on PostgreSQL to isolate any side effects cross concurrently executing mutant kill threads. So I probably want to release this as a gem. I didn't have the time, but whoever listens to this podcast and tries to run and sees problems where so-called neutral errors get reported, we probably need to get to them, should look into this technique to isolate this problem. Did you ever saw a neutral error?
No, I don't remember.
Oh, that's cool. So I might not fit this podcast, but we should talk about them. So mutant has three kinds of mutations. So there are the evil mutations, which should make at least one test fail. Then there are the neutral mutations, and there are the no-op mutations. The no-op mutations are a way to test if your environment is set up for mutation testing perfectly, especially in terms of test reuse. So what Mutant does when it executes mutations against your code base, it first runs injects the code again. so injects a non-mutated version of your code, but it doesn't change the code at all, injects it, and assumes your test should pass now. This makes sure that there is nothing interfering with the way Mutant injects the code. There is no callback being triggered that for some reason alters the test environment, because if the way Mutant injects code, even when the code is unchanged, already turns your tests red, all evil mutations later that should turn the test red have no significance anymore. So whenever you see a neutral or no op error being reported by Mutant, you either have leaked test data from one test into the next test, or leaked data concurrently executing Mutant kill threads. That's the only thing I want to add to this podcast, because when you have the situation, check the repository, we should have a section explaining what to do next soon.
Okay, so it's like almost like for the test library, is like a self-verification process right now, right?
It's a self-verification process built into Mutant to make sure that we are not reporting 100% coverage when the tests already fail when being executed by Mutant, when the code is being executed by Mutant unmodified because of the way Mutant does things. And this happened in the past.
Okay, cool.
Especially that's complex with Rails, because Rails has a very indeterministic environment. There are lots of autoloads going on, lots of implicit behavior from hooked whatever stuff. So it turned out having this kind of test, especially for more complex applications. So RailsEventStore, I checked out the repository during this talk, is quite, which is a good thing. I do not blame that you wrote less code and it's not that complex. But when you look into bigger stuff, which touch the DB, you will run into problems with Mutant, and you need to look into this isolation stuff. Another idea is to limit the concurrency, which obviously makes it slower, but there is a J flag where you can specify to run with less kill threads. When you go to one kill thread, there's obviously no concurrency problem anymore.
Cool. Yeah, and as you said, the RailsEventStore is really a small project, and it's also small by purpose. We don't really want to have it very big, and it is in its core, it does just basically two things. It stores the events, so it helps you with storing the events. It helps you with retrieving the events in different ways, and also it's responsible for publishing, so there is like kind of an observer pattern implemented. We are now working on also allowing people to use it in an async way, so there will be some async support as well. But overall, it's a very simple library, and we want to keep it very, very small and very simple.
Did you ever use Mutant for a client project yet?
No, I think there in one of our client projects, someone started using it in some isolated classes, but I wasn't involved in that. That was after your talk at Wrocław RB 1 year ago. There was a bit of buzz about this, and but we started using it.
Till there was decent Minitest support, you guys, when you're using Minitest, Mutant is not off value right now for you.
Yeah, but sometimes we inherit code bases that use RSpec, and there's no point in rewriting them.
Yeah, sure. That absolutely makes sense. So, with the RailsEventStore, how do you decide which topic, which subjects or units should be 100% mutation tested?
Right now, I think we just say that everything, that client, the facade, it needs to be 100%.
Okay, interesting. Is there anything left to talk about right now? I'm because I'm a first-time podcaster, I'm probably not that good prepared, so you need to give me some kind of hint how to continue. Okay,
so one more question. So when I was working with RailsEventStore with Mutant, I got to the point that, okay, I don't have this active record part covered. So I was thinking, oh, well, let me just implement a fake active record part that I will just replace. So I will replace active record during my test phase. And I started working on that. And after, I don't know, half an hour, I had the subset of active record that we were using, I had replaced. So the tests were working fine. It was just a subset for this project, very small. But then I realized, wait, someone had to do it. And then I was Googling and searching, and I was searching for InMemory active record, fake active record. And it seems like there is no such thing in our community, which was very surprising to me.
It's not surprising to me because active record basically has an infinite interface, and whoever wants to write an in-memory adapter will soon just realize, don't do it, it's too much work. In my opinion, active record is not the way to do database abstraction. And the fact that we don't have a decent in-memory implementation is just just proves this point, because nobody wants to replicate it. The interface is bloated. It does too many things. It squashes so much implicit semantics into the so-called models. I don't think it's doable in a decent way. I think writing fake ActiveRecord implementations for a specific project makes sense, but the universal one will probably never happen.
Yeah, I agree that. Then I realized this actually, that what you said, it's impossible.
Yes.
But then I realized also the second point you mentioned, that but it's possible to implement the subset that we are using. So if you have a huge application, then it's impossible because you're probably using almost everything from ActiveRecord.
Or your dependencies use it. So you pull some dependency on whenever a third-party library which pulls another third-party library which also uses ActiveRecord changes interface users, you have to adjust your in-memory representation.
Yeah, that's a good point. But still, if you have some medium-sized project, I don't know, 100 models maybe, then you can probably imagine implementing it. Because if you have like a very long-running project, which is a legacy, but it's making money, and you will be responsible for it for probably next year.
We thought about doing this, but then it proved out to be more cost-efficient to write this adapter. This ActiveRecord adapter, which basically uses a PostgreSQL adapter but wraps all tests into a serializable transaction we never commit. So instead of redoing ActiveRecord, we basically mitigated ActiveRecord in a way it's not that performant. I totally agree, but we can still use mutation testing on it.
That's a good idea. After our last conversation, I actually sat down and tried to find, okay, let me try this, write my own adapter thing, and whether I can write in-memory adapter, just some basic one maybe. So then I realized it's very difficult.
So I think I should prioritize publishing what we did. So this is commercial client, because it will be of value for others.
Wow, that would be fantastic. But overall, because you said you're wrapping the Postgres adapter, right? So you didn't write your own from scratch?
No. We just make sure that all tests run isolated in the DB. Also a sophisticated version of Database Cleaner, which is, we basically dropped out Database Cleaner because it's not concurrency safe. And it's also an edge case which will probably only work correctly on PostgreSQL because the concurrency model does not suck. So the thing is that under mutation testing, we still hit the DB, we still get the speed penalty, but for this specific client, being able to mutation test ActiveRecord models, because they won't go away because of a big third-party Rails engine we need to use, and there's no way we will re-implement this, we still wanted to use mutation testing on this ActiveRecord-infected units. So instead of writing the in-memory adapter, which is impossible, we decided to fix the way ActiveRecord tests are isolated from each other. We are wrapping in serializable transactions we never commit, and you need to, it's out of the scope of this podcast, but a serialized transaction has several concurrency guarantees, which will blow up in case you try to commit it, but when you never commit it, you basically get a full or perfect enough fork of the database. And when you create this fork on the empty database, all tests are perfectly isolated from each other, at least on PostgreSQL.
Wow, I'm looking forward to trying it once you publish it.
Sure, I will. After this, I think it's I need to beef up the mutant documentation on this NoOp stuff and on especially on this ActiveRecord stuff. And part of this should be at least a gist from the spec from this RSpec addition we did, which executes the required PostgreSQL statements prior and after the test to totally fork the DB state. I think I can do this next week or so.
Okay, great. So I think it's time to slowly wrap up. Is there anything else that you would like to add to the conversation about mutation?
No, because I'm a first-time podcaster, I'm totally overwhelmed by the fact that I'm getting recorded. So my brain is empty.
You did very well.
I can answer to any question, but right now I'm like, I cannot find anything I want to talk about, but please ask anything. I'm very happy to reply.
I think we've covered all the topics that I wanted to mention. So
perfect.
Markus, it was really great to talk to you. I'm really inspired by your work, and also for all the people who listen to us. I look at the Mutant code base, and you can, if you are just starting with Ruby, or you're already doing Ruby for several years, but you want to see a good example of a Ruby code base, then Mutant is the place to go and look. It's a very advanced project overall, but you can see at the certain classes, the code conventions, really, really good. Simple code, very readable.
Thank you. But one thing, Mutant is not fully self-covered yet, and I'm aiming for self-coverage, but self-covering a mutation testing engine requires some very funny hacks, but this is out of the scope of this podcast. But I'm okay. Heading towards this. So Mutant 1.0 will never happen unless Mutant is 100% mutation covered.
That would be a nice point. Yeah, so that's exactly 1.0 I can imagine being released.
Exactly.
So thank you very much and see you.
Yeah, see you later. Bye.
Bye.